Alright, you guys, this is section 8.5 called Angles of Elevation and Depression. And the idea of this section basically is to apply the trigonometry that you just learned in real life situations. And so specifically we want to talk about angles of elevation and depression, and everything is based on what we call the horizontal line, which is a line that goes from left to right. And if the angle goes up from the horizontal line, it's called an angle of elevation. Up is angle of elevation. And if the angle goes down, it's called the angle of depression. So elevation and depression, up and down. So be careful. You have to read carefully to label the correct angle. And remember that a line of sight forms a horizontal line, and I'm going to demonstrate that. Alright, first of all, let's be able to even identify angles of elevation and depression. So describe angle 1 and angle 2 as they relate to the situation shown. Alright, first of all, we're going to make sure we understand that this is an airplane and that this is the tower, the radio tower. So we're just going to call it a tower. And so let's start with angle 1. Okay, where's angle 1? Well, find the horizon. Here's my horizon. And this is the line that goes down. And so it's actually going what? Down. Down means depression. So angle 1 is the angle of depression. Now you have to be more descriptive. From what? From the airplane to the tower. So knowing the words from and to make a difference as well. Or you can say angle 1 is the angle of depression to the tower. So be careful of your labels. Alright, let's talk about angle 2. Angle 2. Find the horizon is touching. This is the horizon. This has to go up to touch this line. So this is an angle of elevation. So is the angle of elevation. Now here's where we have to be descriptive. From where? It starts at the tower. From the tower to where? The airplane. So this is the idea of angle of elevation and angle of depression. It's based on the horizon line and where the angle is going to. Alright, let's do an example. A surveyor stands 200 feet from a building to measure its height with a 5-foot tall theodolite. Now a theodolite, this word, if you had to look it up, it's a measuring device. It's a machine that measures angles. So theodolite, spelled it wrong. Theodolite is a machine that measures angles. It sits on a tripod to make it stable, and it measures angles when you are able to click a button. Surveyors use it. Okay, now once again, this is a word problem, so we are going to draw a picture. Always draw a picture of the situation. Okay, a surveyor is standing 200 feet from a building to measure its height. So let's draw the surveyor. Here's the ground. Here's the tall building. And here's his little measuring device on the little tripod. Okay, he's going to stand 200 feet away from this building. The theodolite is 5 foot tall, and this is what's measuring the angle. And they tell you the angle of elevation, which means it has to go up. Now, where is the line of sight from the theodolite? So we're going to make a horizontal line of sight And from this horizon, it measures the top of the building. Here's my angle of elevation going up to be 35 degrees. How tall is the building? Okay, so I want to talk about what's happening here. We have this right triangle. I know this is 200. This is 35. This is x. Now be careful. How tall is it from here to here still? Well, that's the original height of my theodolite. This is already 5 feet. So we're going to find our x, and we're going to add it to the 5 feet to find the total height of the building. And to find x, we're going to use trigonometry. So to this 35-degree angle, this is my opposite side, this is my hypotenuse, this is my adjacent. We're not using the hypotenuse. O and A, SOHCAHTOA, that's tangent. So tangent of the angle is equal to opposite over adjacent. We're going to solve this equation by multiplying both sides by 200. And when you solve this equation by multiplying both sides by 200, you find out that your value of x is equal to 140. Remember, this is not your answer. You found this is 140. We still have to add it to the 5. So the height of the building is 145 feet tall. And now I have my problem. Okay, let's do one more example and then I'm done. Let me clear this ink. An airplane is flying 3,500 feet above the ground, and it begins a 2-degree descent. Descent. This means like depression, going down. That's what this word means. To land at an airport. So let's draw a picture. It's a word problem. We're going to draw a picture. Alright. Here's my airplane up in the air. Now he's above the ground. Okay, here's the ground. Let's pretend here's my little airport right here. Let's call this A for airport. Now the pilot right now is looking, here's his line of sight. And then he's going to move down to hit the airport. So from here to here, this is his angle, and it says it's a 2-degree descent, very small. And this airplane is 3,500 feet above the ground. Now be careful. How many miles from what? Airport is the airplane. Airport, airplane. Airport, airplane. This is what I'm trying to find. Here's my right angle. Where's the angle in the problem? We don't know. There's no angle in my triangle. But there is. You guys, don't forget about our special angles we learned in the first semester. These are called alternate interior angles. And if you have parallel lines, of which your horizon and your line of sight always is, then you have alternate interior angles that are congruent. So if this is 2 degrees, then this by chance also has to be 2 degrees. And now I have an angle to work with. So to this angle, this is my opposite side, this is my hypotenuse, and this is my adjacent. We're not working with this. O and H is sine. So I take sine of the angle and set it equal to opposite over hypotenuse. Now don't forget, with these types of problems you have to switch because the variable is on the bottom. So h, your hypotenuse, or in this case our x, is going to be 3,500 over the sine of 2 degrees. So when you type this into your calculator, here's what's happening. Let me change this to x, you guys, because that's what we're trying to find. X equals, and you're going to get a huge answer, 100,287.9. Now what's my label? This is in feet, because I was given 3,000 feet above the earth. But be careful, they want to know how many miles the airport is from the airplane. So you have to convert. And I told you that 1 mile is in 5,280 feet. So if I'm given this many feet and I want to know how many miles it is, we have to divide by 1,280. So we're going to divide by 5,280 feet in a mile. And we're going to find out our real answer is approximately, when you divide this out, you get 19 miles. And you're done. Okay, these are all word problems that you have to draw pictures for. So you have to draw a picture, write your equation, then solve. And label. Draw a picture, write your equation, then solve and label. Fabulous. You guys have fun.